Hello, everyone. Welcome to our seminar on first differences. So we use first differences when we have a table of values to figure out if our graph is going to be a linear function or a nonlinear function with just the table of values without having to graph it or put it on Desmos in any way or any graphing calculator software. So the first thing we're going to talk about is how do we complete a table of values when we have an equation? So you can see I have this equation y is equal to negative 2x plus 7. You always have to start with your x values, and when you're picking your x values, you have to make sure they're going up in a consecutive manner. For example, our x values today are going up by 1. We start at 0, then we go to 1, 2, 3, 4. We could also start at 0 and then go up by 2s or go up by 3s. As long as we're going up by or down by a consecutive number, then that is the correct way to make a table of values. Now, with each value of x, so for example, right now, I'm going to start with x is equal to 0. Well, I have to plug that value into my equation. So instead of y is equal to negative 2x plus 7, I'm going to plug in negative 2 times 0 because that is my x value. I have to figure out what negative 2 times 0 plus 7 is. In order to do this correctly, I have to use my BEDMAS rules. So we multiply brackets first, and then we perform the addition operation. So negative 2 times 0 is 0 plus 7 is 7. So that is going to be my corresponding y value when x is equal to 0. Now, when x is equal to 1, I'm going to plug in my 1 for my x. So negative 2 times 1 is a negative 2, plus 7 is going to give me the value 5. And I can keep doing that. I can turn this into x is equal to 2. Negative 2 times 2 is negative 4, plus 7 is going to give me a y value of 3. And so on and so forth. If we turn this into a 3, negative 2 times 3 is negative 6, plus 7 is positive 1. And my last value is actually going to be negative 1. So that's how we fill out our table of values. I'm just going to zoom in a little bit. Now, to calculate first differences and in order to make a conclusion, you'll notice when I was filling out the table of values, I went from top down. But what students forget is when you're calculating your first differences, because my formula is y2 minus y1, and the pattern is y3 minus y2, or y4 minus y3. We actually start from the lowest y value and we subtract like this. So what y2 minus y1 means is you take your second y value and subtract the one before it. So that will actually give me, if I'm filling out my column, 5 minus 7. But what might help is just start from the bottom and work your way up. So minus 1, minus 1. Then we go to positive 1 and we subtract the value before it. So positive 1 minus 3. And then we start at positive 3, subtract the value before it. 3 minus 5. And when we actually perform these operations, well, a negative 1 minus 1 is going to give me a value of negative 2. 1 minus 3 is also a value of negative 2. 3 minus 5 also gives me a value of -2. And 5 minus 7 also gives me a value of -2. So because all of these first differences I've calculated are the same, that means that my first differences are constant. It's another way of saying they are the same. And therefore, the relationship is definitely a linear relationship. The graph is going to be a straight line, linear. Okay, that's a very easy process, easy to understand as long as you're starting from the bottom and going all the way to the top and knowing that we're only talking about the y values, not the x values. So for this particular equation, y is equal to x squared. Well, a hint is, first of all, it's not in the form y is equal to mx plus b. And you'll notice I've already plugged in all the values of the table of values. 0x squared. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. But when we're going ahead and calculating our first differences, and maybe I shouldn't write that arrow because that is going to confuse you, we actually start, use my purple, start from the bottom and move to the top. So 16 minus 9, 9 minus 4, 4 minus 1, 1 minus 0. So we're starting from the bottom, going all the way to the top. Arrow's a little bit crooked there. And we'll notice when we actually perform our addition and subtraction, these are all not the same number. So our first differences are not constant. Therefore, the relationship is non-linear. Okay, and if I actually graph this using graphing software, you'll find that this graph looks like this. It's a quadratic function with a parabola, so it's definitely not a straight line. Another case, we have a nonlinear function. Again, we're going to just focus on our y values. This is a power function, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. And when I actually fill in my table of values and move from the bottom, subtract the y value that comes before it. So always starting from the bottom of the table of values. Again, we get 1, 2, 4, 8. Those first differences are not constant. Therefore, the relationship is also not linear. It's not a straight line. Now, sometimes you're given a random table of values. It doesn't have an equation attached to it. So let's explore how to fill out a table like this if you have it on the test. And if you have this on your test, good chance you're going to have a separate line for each calculation of the first difference. So I'm going to start with -9 minus 5. Write that down, -9 minus 5. If I solve that, oh, I have actually made a mistake. It's -9. I am subtracting, but notice that the negative, it's -9 minus -5. So I almost made a very common mistake. -9 minus -5. That's the same as -9 plus 5, which gives me a value of -4. Now, if I take -5, and again, I have to be very careful when I have two negative numbers. -5 minus -1. So that's the same as -5 plus 1, which also gives me -4. Now, -1 minus 3, -1 minus 3. Both have the same signs. So when we have the same signs, we keep the sign the same and add the numbers. So we have a -4. And finally, 3 minus 7. So positive 3 minus 7. So I have a positive and a negative number. So in this case, the larger number is negative, so my answer is negative. And when we subtract 7 minus 3, we also get negative 4. So my first differences are all the same. Therefore, this is a linear relationship. Another way of saying a straight line, a linear relationship. Example 5, again, we start from the bottom and subtract the value before it. 55 minus 40, 40 minus 25, 25 minus 10, 10 minus negative 5. Be very careful of the double negative. 10 minus negative 5 is the same as 10 plus 5. So we have a linear function because all our first differences are the same. 15, 15, 15, and 15. And the last one is a little bit tricky because when I take 10 minus 2, I get 8. 2 minus 0 is positive 2. 0 minus negative 2 is also positive 2. Negative 2 minus negative 10, which is the same as negative 2 plus 10 because you have a double sign, gives you a positive 8. Now, just because these two are the same and these two are the same does not mean we have a linear function. All the first differences must be the same number in order to have a linear function. So in this case, this is nonlinear. So I hope this assignment helped you understand how to calculate first differences, and therefore you can be very successful on our slope test.